All right, we're going to pick up on section 3.3, measures of variation. So we just went through measures of center, and we talked about a couple different ways to describe a measure of center, and then we'll learn in this section how to describe the consistency of the data, and we call that a measure of variation. So here's a very simple example where we have waiting times of 3 customers for 3 different banks. And so bank 1 had a waiting time of 6 minutes for each customer. And then bank 2 and 3 were slightly different. And so we can calculate the mean waiting time for each bank. And so for bank 1, everyone had a waiting time of 6 minutes. And so the average, of course, would then be 6 minutes. Okay, so 6 minutes there. Bank 2 would be 4 plus 7 divided by 3, so that's also 6 minutes. And then bank 3 is 1 plus 3 plus 14 divided by 3, so that's also 6 minutes there. So we can see that each bank had the same average waiting time. But if you look at each bank individually, they're much different. Bank 1 has a lot more consistency. All the numbers are the same, whereas bank 3 is inconsistent. 2 people waited a pretty short time, and then the third person had to wait quite a bit longer. So we need some kind of measure to describe the difference in consistency between the 3 data sets. And so if we wanted to, in words, just describe what was going on, we would say that bank 1 was the most consistent with regards to waiting time, and bank 3 was the least consistent, with bank 2 being in the middle. Okay, so we could say bank 1 has the least variation from waiting time from person to person, and bank 3 has the most variation from person to person with regards to banking time. Okay, bank 3 has the most variation from person to person. Okay, so we're just going to describe some ways to quantify that. There's 3 measures of variation that we commonly calculate. One is the range. Another one is the standard deviation. We're going to talk about both of those today on this video. And then in class, you're going to learn about the IQR, or the interquartile range. So the range is very simple to calculate. It's just your maximum observation minus your minimum. And so for bank 1, all the observations were 6, and so the range is just going to be 6 minus 6. And that's equal to 0. For bank 2, the maximum was 7 and the minimum was 4, so the range is going to be 3. 7 minus 4, so the range is going to be 3. And for bank 3, the maximum was 14 and the minimum was 1. So we just take 14 minus 1, and that's equal to 13. These all have units. They're all minutes. Okay, so bank 1 has the smallest range, and bank 3 has the largest. And that's what we would expect by our description of the data. Bank 1 is the most consistent, so it had the smallest range, and bank 3 was the least consistent, so it had the largest range. So the range, although it's very easy to calculate, it happens to be very sensitive to outliers, and that's because it uses only 2 numbers, the max and the min, so any outliers that happen to be in the data set are going to be used in calculating the range. So the standard deviation is a more common measure of variation that we use. And what we do with the standard deviation, we calculate it using this formula right here. And we look at the deviations from the mean. And so it calculates the distances from the mean. And so data sets with observations close to the mean, you're going to have smaller standard deviations than data sets with observations further away from the mean. So this is taking each value and subtracting the mean, squaring it, summing that, and dividing n minus 1. So what it's doing is calculating about the average distance from the mean that the observations fall. Okay, so there's some properties to the standard deviation. The first property is that it measures distances or deviations from each observation to the mean. That's one property. Second property is always positive or 0. It can't be negative because we're talking about distances. Distances are always positive. It's sensitive to outliers. So we also say not resistant. It's not as sensitive as the range, but it's still sensitive to outliers. And the units are the same as the variable. And so for our example, the standard deviation would be minutes because the units were minutes for waiting time. So that's the properties of the standard deviation. We're not going to do too many of them by hand. In fact, you might not do any of them by hand. But I'm going to walk through one example by hand. When you use your TI calculator and you want to compute the standard deviation, you want to look for the option that says, I'll just write it here. No, I'll write it up here. Oops. That says S subscript S. That's the standard deviation on the TI calculator, or you can use StatCrunch. We're going to just do one example by hand and walk through this formula right here. And we're going to use bank, let's see, which one are we going to use? We're going to use bank 3. And bank 3, remember, had the following wait times, 1, 3, and 14. And we've already calculated the sample mean, which was 6 minutes. So now I want to calculate the 3 distances from the mean by subtracting the mean off of 6. So I have 1 minus 6, and that's going to be negative 5. And then I have 3 minus 6, so that's going to be negative 3. And then I have 14 minus 6, and that's going to be 8. Okay, so what I did here was I just did this part of the formula right here. Those are the deviations from the mean. And then I want to do the second step, which is squaring that. And so I want to take each number I calculated in step 2, and I want to square it. And so I have negative 5 squared. That's what makes everything positive. Negative 3 squared is 9, and 8 squared is 64. Okay, so that's the second part. That's just squaring it. That's doing this right here. Now we want to add up all the numbers. That's what the sigma represents. That means sum. Okay, so I want to take 25 plus 9 plus 64. And that gives me 98. Okay, so let me show you where we're at on the formulas. Now we're at the numerator. I've done this whole thing right here. Now I have to divide by n minus 1. And so I take 98 and divide by 2. And that's equal to 49. And now I've done everything but the square root, so I take the square root of 49. And that's equal to 7. And the units are minutes. So the standard deviation to bank 3 was 7. Okay, so that describes standard deviation. I just want to show you something else. Oops. Or not.